So this is our local min. And that's it. Done and dusted. So question 5 is next. And this one's a little bit shorter. So what it says, find the coordinates of the local max and local min point on the curve. So this is exactly the same as what is being asked in question 2, essentially. But you can see the difference, okay? In question 2, it asks for the coordinates of the turning point, meaning that there's only one. In question 5, it asks for the coordinates of the local maximum and the local minimum. So I know that I'm getting 2 points now in this case. So I'm following the same process as I did in question 2. Let's look at those rules once more. I find my derivative. I put my derivative equal to 0. I solve for x, and then I use those x values to find y values. Okay, now in this case, I'm going to have 2 x values, if you recall. So let's see how we got there. So the function is given to us. 10 plus 15x plus 6x squared minus x cubed. I've got a cubed function, all right? So the first derivative is the line underneath there, 15 plus x squared, 15 plus 12x minus 3x squared. I then use that to solve for x. So that's a quadratic function, a quadratic equation, and I'm going to solve that by factorizing. You could also fill those values into the minus b formula if you so wish. So you can see what I've done. I've rearranged this so it looks like a quadratic equation. I've got x squareds, then x's, then numbers equals 0. I've gotten rid of the minus sign at the front because that makes it a bit easier. So I've changed the signs right across. And then I've divided by 3. When I'm factorizing, I want to have the smallest number I can at the front here at the x squared value. So I notice that 3 and 12 and 15 can all be divided by 3. So that's why I've done that. And then I can factorize that nice and simply. So I've got x minus 5 and x plus 1. So that gives me 2 x values. X is minus 1 or x is 5. So using those x values, I have to just solve for y values. Nice and straightforward, okay? So I substitute in my minus 1 value for x, and I get 2 for y. So that gives me one of the points, minus 1, 2. And then when x is equal to 5, I get 110 as my y value, which is a big number, okay? So I've now worked out the coordinates of the local max and the local min. Minus 1, 2, and 5, 110. So let's look back and let's pop them in and see what that looks like in GeoGebra, if it works for me. So, what we want to get rid of. Hang on for a second. Let's go back. I'll just read through this bit first and then it'll hopefully open a bit better for us. So what I've mentioned here, 5, 110 has the larger y value. So if you look at the y values of these 2 points, 2 and 110, that shows me that the 110 has the larger y value than the 2. And whichever one has the larger y value is the maximum point. So I can say then, therefore, 5, 110 is the local max and minus 1, 2 is the local min. And that's what we're hoping for. So I'm going to get rid of those. Don't need any of those things. And we're looking at question 5, which is this function here. So that's the function, okay? Now, if I zoom, you can see that's my local min, which is minus 1, 2. That's the point that I worked out algebraically there, minus 1, 2. And you can see that that's at the bottom of the curve. That is the local minimum. And if I zoom right out, remember, because this number was really big, 5, 110. So you can see on the graph, it goes to 5 at the bottom here on the x-axis, and it goes all the way up to 110 on the y-axis. So that point up there, F, is my local max, because that's at the top of the curve as it's bending, okay? So the larger y value is the one that gives you your local max, and then the other one will be your local min. Hence why we are able to say those things there at the bottom. 5, 110 is my local max, and minus 1, 2 is my local min. Right, that's question 5. I know we're in a long video here, lads, but a lot of hard work expected in these problems, so we got to go through it bit by bit. Question 6 then, finally. We have a function, okay, it looks very different to what you're used to. It's got stuff in brackets, it has a squared in it there to square those brackets. So I'm going to have to do a little bit of work on that to start off with. First part, it says write fx in the form like we usually would, okay? Cubed, squared, x's, numbers. So I'm going to have to multiply out all those brackets and end up with my function. Now I'm finding the coordinates of the local max and the local min, same as we did in question 5. Then I'm finding the coordinates of the points where the curve intersects the x and the y axis. So that's new. Draw a rough sketch, that's new. And then write down the range of the values, that's new. Okay, so we go to my written examples here. First and foremost, the function is given to me. All right, you can see that the function at the very top there. The brackets on the left are squared, so I multiply them by themselves, and I've multiplied all that out, multiply it out by the next set of brackets, so I end up with that big long line of algebraic terms, and I substitute, or I add and subtract what I can, and I end up with that as my function at the bottom there, minus x cubed plus 3x plus 2. So that's my function, okay? I then, so that's it in the form that we were asked to find it in. It doesn't have an x squared in it, and you could say 0x squared, but we know that 0x squared is equal to 0, so I left it out. We wouldn't have to write it in there, okay? Part 2 asks for the turning points. I got to find the local max and the local min. So we did that in question 5. That's exactly the same process. I get my first derivative, so I go from minus x cubed plus 3x plus 2 to the first derivative there, the f prime of x. I'll put it equal to 0. I solve for x, and you can see again x squared is equal to 1. That happened in one of the questions earlier on. So x is equal to plus or minus 1. And then I substitute those values in, and I get my local max and my local min. So I'm not running through that again because that's what we've just done in the previous question. Alright, I can just see that the higher y value is the local maximum point. So 1, 4 is my local max, and minus 1, 0 is my local min. Then question 3, I'm looking for where the function crosses the x-axis and the y-axis. Okay, now the function crosses the x-axis where y is equal to 0. That's a rule as always. So wherever we have a point where the y value is 0, that means that that is on the x-axis. So the one point, the local min that we worked out a few minutes ago, is one of those points. It crosses the x-axis at that value. Now, to work out what I could do here, I've got my function again, and I'm putting it equal to 0. Remember, because y is equal to that function. So I could solve for x again. Now, look what I'm saying here. It says to sub in values to solve for 0. Okay? So to solve that function equal to 0. Now, what I've done, when x is equal to 1, you can see that up here for my local maximum. When x was equal to 1, y was equal to 4. So that's not correct because I want y to be equal to 0. When x was equal to minus 1, y was equal to 0, like in my local min. So then I've gone and subbed in 2. So you can see what I've done there. I've gone sub in 1, sub in minus 1, sub in 2, sub in minus 2. Now, generally, if you're asked a question like this, you'd be asked to substitute in those values, but you wouldn't be expected to do many of those. So I would think that when you're doing this and you're substituting in values, if you get past plus 3 and minus 3, they won't ask you any higher than that because there's a lot of work in substituting those values in. Okay, so you can see here I've subbed in 2 and that does equal to 0. So I've subbed in x, subbed in 2 for the value of x, and I've put it into the function, and it does equal to 0. So that's another point on the curve where it crosses the x-axis. So I have 2 points now where this curve crosses the x-axis. I have minus 1, 0, and I have 2, 0. Alright, to finish that off, and you can see I've got my graph drawn here, and I'm going to match it against what's done on GeoGebra in a minute. So, as I've said there, those 2 points at the top, that is where the function crosses the x-axis. The last point, the last thing I need to find, is where it crosses the y-axis. So remember, I've said here, the function crosses the x-axis where y is equal to 0, and vice versa. The same thing happens the other way around. The y-axis, the function crosses the y-axis, where x is equal to 0. So I sub in 0 as my value for x, and I can work out then the y-intercept, whereabouts that point, whereabouts that function crosses the y-axis, and that is 0, 2. So now I have 4 points that I want to put into my graph, and I should be able to sketch it based around that. Okay. So you've got the local min, which was minus 1, 0. You work that out in part 2. Minus 1, 0. The local max, 1, 4. Again, we work that out in part 2. And then the x-intercept, the other x-intercept, which was 2, 0. And the y-intercept, which was 0, 2. So we've got 4 points there that we can pop onto the graph, and then all we got to do is put the curve. Now the important part is to remember which part is which. So I know that minus 1, 0, the point on the left hand side of the graph, I know that is the local minimum. So I know that the function is coming down and it's turning upwards when I get to that point. It passes through the y-intercept, it hits the local max at 1, 4, and then it comes back down, because the local maximum is where the curve starts to turn back down again. That's the local maximum. And then we go down and we get our x-intercept. Okay, so that's all that's going on in question 6. Let's look back to finish that off. The last bit, it says, hence, write down the range of values of x for where the function is increasing. Okay, so I haven't actually written this in the question, but let's have a look. I want to know where the values of x, okay, the values on the x-axis, where the function is increasing. So the function is increasing where the line is going upwards. So where do you see the line going upwards in the function? It goes upwards when I get from minus 1 to 1. Okay, so between the local minimum and the local maximum point is where the function is increasing. So that's what we can say. When minus 1 is less than or equal to x, and x is less than or equal to 1, that's where the function is increasing. And that's all there is to it. So you got to remember, where the function is increasing, where the curve is moving on an upward slope, where we're cycling up the hill like we've said before with the slope. If I see that upward slope, it means that the function is increasing. You can see the function is going down before I get to minus 1. The function is going down as I go from the local max down past the x-intercept and so on. So the only part where it's going upwards is between minus 1 and 1. So that's where the function is increasing. Now I know that was a long one, lads, but there was a lot of work expected in those. I'll give you a couple of bits to do for today, and then we'll see how we get on after that. Thank you very much.